1.2 is on exploring compound interest. So the last section we were just looking at simple interest when investment was, interest was being calculated once per year. Now sometimes the interest was being paid out more than once a year, but it was still being calculated once a year. So what we're looking at this section is comparing the compound interest to simple interest. So compound interest is the interest that is earned or paid on both the principal and the accumulated interest. So remember before what I said in the last section, is in simple interest, whatever you've earned in interest in year 1, by the time you get to year 2 and year 3, you don't earn interest on that. You just earn interest completely on the amount you invested. Compound interest works differently. Compound interest, you're going to actually earn interest on your interest. It's compounding, so it's adding up onto itself. Guaranteed investment certificates can earn either simple or compound interest. If the GIC earns simple interest annually, the same amount of interest is earned every single year. If the GIC earns compound interest annually, the interest at the end of the first year is earned on the principal, but the interest on the end of the second year is earned on the principal plus the interest from the first year. Each year after that, the interest is earned on the principal plus all the accumulated interest. So that was just kind of saying it another way. Compound interest means you get to earn interest on the interest you earned in previous payments. So it says both Ewan and Rena received a $1,000 prize in a story writing contest. Ewan bought a $1,000 simple interest GIC with his prize money. It is a 5-year term and earns 3.6 paid annually. Rena bought a $1,000 compound interest GIC with her prize money. It also has a 5-year term and earns 3.6% paid annually. How do the future values of Ewan and Rena's investments compare at maturity? So we're not going to do this as a partner. What we're going to do is just compare these. So using A is future value is equal to P times 1 plus RT to determine the future value of Ewan's investment. So Ewan is this, he's got the simple interest. He earns it once a year, and that interest doesn't earn interest. So we know the principal amount is at $1,000 that he invested. Our rate was 3.6%, so 0.036, and our time that he did this in was over 5 years. So using our formula, A is equal to 1,000 times 1 plus 0.036 times 5. So when you put that in your calculator, you find that at the end of his 5 years, he has earned, or his investment is worth 1,180. For Rena, what we're going to do is we're going to use a table of values to find out what her interest is going to be, or what her final investment is going to be. So she's invested $1,000. That's what she starts at very beginning of this whole thing. So her value of the investment at the start of year 1 will be $1,000. At the end of that year, she's going to earn her interest. So her interest was, remember interest, simple interest is just PRT, so she's got 1,000 times that 0.036 times 1 year, so at the end of that first year she has $36. So her accumulated interest is $36, so the value of her investment at the end of that year will be $1,036. So she starts out her year 2 at $1,036. So now when you calculate her interest on that, this is going to be 1,036 times that 0.036 times 1 more year. So that would be 3730. So she's earned in total then another $36 on top of that $36, she's got $73.30 for a total of $1,073.30. She starts out year 3 at $1,073.30, so her interest is going to be $1,073.30 times 0.036, so she would earn $38.64. So if we add that on to our $73, she's got $111.94, so her total would be $1,111.94 at the end of 3 years. So year 4, she's got a $1,101.94. Interest on that would be $40.03. So she had 111 before, we add that on, it's 151.97. So her total would be 1,151.97. So year 5, she's starting out at 1,100, oops, got carried away with my ones, 1,151.97. Interest on that is $41.47. So her total interest earned is $193.44. So her total value is $1,193.47. So I'm not going to graph these on here, but you could plot those. So the simple interest one again is going to be just a basic line where you had, what was his? So you're starting at 1,000, so your y-intercept, so this would be for, what was his name, Ewan? You would have y is equal to 1,000 was our intercept, and then it was that 0.036x for every year that you would go up. For Rowena's, you can't, it's not going to be a straight line because it'll go up, it'll be a progression because it's going to continue to rise, but it won't make a perfectly straight line. And you can put that in, just plot those points that we have here on the graph to find those, but it gets a little bit messy, so I'm not going to bother doing that. So the last part says, how much would you need to invest at 3.6 simple interest to earn the same as Rena in 5 years? So, before I answer this, I'm just going to go back here, because the initial question was to compare what the difference is between the two at maturity. So when all was said and done at the end of 5 years at simple interest, he had $1,180, and she had $1,193. So she was able to earn a little bit more, not necessarily a lot, but because it wasn't a huge investment, nor was it a big interest rate, she still made out an extra $13 more than he had. So the C part asks, how much would he need to invest at a simple interest rate to have the same amount as Rena did in 5 years? So we're looking at future value. We're trying to find out how much will you need to invest. So right here we need to find out what is the principal to have the same as Rena, so that's a future value if they invested for the same amount of time. So remember your future value formula, you had A is equal to P plus PRT, or A is equal to P times 1 plus RT. So if we want our future value to be Rena's amount, so that was $1,193.44. We want to know what is that principal supposed to be. So we're going to do P times 1 plus, and it's the same interest rate, 0.036 for the same amount of time, 5 years. So this is 1193.44 equals P times 0.036 times 5 is 18 So times or plus 1 is 1.18. So if I divide each of these by 1.18, oh, and my answer is smudged here. And so when you divide, and I just have to put my calculator here, 1,193.44, and you divide it by 1.18, you have 1,000, whoops, not one decimal, $1,011 and about 39 cents. So he would have to start out with just over $11 more with his initial investment in order to end up the same as Rena did with her compound interest. Excuse me, I'm yawning. So it says compound interest is determined by applying the investment rate to the sum of the principal and any accumulated interest. So you're earning interest on your interest is basically what it's saying. Previously earned interest is reinvested over the course of the investment. If the same principal is invested in a compound interest account and a simple interest with the same interest rate for the same term, the compound interest investment will grow non-linear, will grow faster than the simple investment. So simple investment is always going to be that straight line. So this one here, whereas the compound interest is that blue, so it's not going to be, it's more of a quadratic looking curve. So financial institutions pay compound interest on investments at regular equal intervals. If it is paid annually, it's calculated at the end of the first year and then added to the principal at the end of the second year. The interest is calculated on the balance at the end of the first. So principal plus interest earned. This pattern continues every year until the end of the investment term. Okay, so there's 3 questions for you to work on this section.